Hi, everyone. Welcome to the webinar today. My name is Chris Doran. I'm a technical sales specialist with ITM Instruments. Thanks for joining us today through our ITM University, and we appreciate you taking the time to be with us today. Today, we'll be covering the essentials of pressure calibration. It's a fundamental topic, and when it comes to ensuring measurement accuracy, maintaining equipment reliability, and meeting compliance requirements. Whether it's part of your day-to-day operations, maintenance programs, or audit readiness, having a solid understanding of calibration basics can make a real impact. Over the course of the next 40 to 45 minutes, we'll walk through key principles, best practices, and some common pitfalls to watch for when performing pressure calibration in the field. We'll also touch on ways to improve consistency and confidence in your measurement processes. As promised, all attendees that stay to the absolute very end of the webinar will automatically be entered into our contest to win $100 on your next or future online orders with ITM. At any moment throughout the presentation, feel free to use the chat feature or the question feature to drop a question in there at any time. We do have about 10 to 15 minutes allotted at the end of the presentation to cover any and all questions, so please put them in there at any point during the presentation. And a quick note, ITM works closely with industry partners like AMETEK. This ensures our ability to deliver complete test and measurement solutions. Our focus is on providing reliable tools, strong technical support, and practical guidance that you can apply in the field. Getting started today, our presenter today is Kevin Dion. And Kevin, I will pass it over to you.
Thank you, partner. So hello, everyone. My name is Kevin, and I'm also a technical sales specialist with ITM Instruments. In my role and Chris's role, we work closely with customers across a wide range of industries, supporting pressure measurement, calibration, and instrumentation applications. My focus is not on just supplying equipment, but also on helping ensure measurement accuracy, compliance, long-term reliability in the field. Before we dive any deeper, I'm just going to turn my camera off to avoid any freezing or any lag. It'll be back on during the question portion of the webinar later on. So I'd also like to mention that ITM Instruments works closely with Crystal Engineering, and today's webinar is in partnership with AMETEK. It reflects our ongoing promise to deliver accurate, practical, and manufacturer-supported pressure and calibration insights directly to our customers. With that, we'll get into today's agenda points. So we'll begin with why calibration matters in pressure measurement. So understanding how calibration protects measurement confidence, process control, safety, and compliance. We'll then move over to building measurement integrity. We'll focus on accuracy, calibration, reference recording, where we'll define the accuracy specifications, controlled calibration practices, and reference standards that we see often to ensure reliable pressure measurements. We'll end with calibration management and best practices before we dive into the Q&A that I spoke about before. So, in any pressure-based system, accurate pressure ensures consistency. Even small pressure errors can lead to large variations in performance output. The system may be operating, but it's no longer operating as intended. So calibrated gauges provide visibility into what's actually happening inside of a system. They help identify issues like failing regulators, blocked lines, leaks, or restrictions before they turn into massive issues. When a gauge drifts out of calibration, it masks those issues. So everything appears to be normal on display while your system slowly moves out of control. And by the time that this becomes obvious to the technician working, it's usually already caused downtime, safety concerns. We'll dig into some industry examples shortly. But overall, that's why calibration isn't just a requirement. It's how you protect your process from silent drift. So pressure measurement plays a critical role across a variety of industries. I'm sure the people attending, you probably all work in different industries, but the ones we typically see on a day-to-day, week-to-week basis, they're on the screen there for you: oil and gas, chemical processing, water and wastewater, food and beverage, industrial plants, and manufacturing. This is not all of them, of course, but these are the industries that we typically see a high demand for. In oil and gas applications, pressure is typically tied directly with safety and efficiency. It's used to monitor gas flow through pipelines, verify conditions at compressor stations, detect moisture, corrosion, or restrictions before they become large problems. Differential pressure is also pretty key in this industry. Chemical processing, it's usually safety-related concerns. In water and wastewater treatment, pressure is used everywhere. So from distribution and filtration to pumping and process control, reliable pressure measurement and calibration help ensure that your systems are operating efficiently. Food and beverage is a big one with us as well. Pressure works alongside temperature and flow to maintain product quality. This is seen in production, storage, transportation. So that's a big one as well. And then industrial plants and manufacturing plants. I mean, prevention is the key role in this industry in particular. Prevention, because in doing so, you save yourself in the future. We'll go over that a little bit later, but costly downtime, rework, energy consumption, etc. So in sum, the core takeaway is this: no matter the industry, when pressure is measured accurately and verified through calibration, your operators gain confidence, the processes stay under control, and problems are caught before they turn into failures. We'll be moving on to our next agenda point now. This one's a little bit more in depth, a little bit more technical. So in pressure measurement, accuracy, calibration, and reference standards are often discussed together, but they serve very distinct and specific roles. So I'm going to walk through each of these concepts individually, and I'm going to show how they're supported by different crystal engineering instruments, not from a product standpoint, but from a measurement function standpoint. The goal here is to clarify where each tool fits in the measurement chain before we move on. So when we talk about understanding accuracy, it's important to look beyond a single specification on a data sheet and understand how that accuracy behaves across the operating range of an instrument. So accuracy is often expressed as % of full scale. What does this mean? So for example, if a gauge is specified at 0.5% of full scale accuracy on a 5,000 PSI range instrument, that corresponds to a maximum error of 25 PSI. So how did I get that? 0.005 represents the accuracy in decimal form. We multiply that by the full PSI range. So in this case, 5,000, and that gives you your error rate of 25. So that may be completely acceptable for you, depending on your application. That being said, it's important to note that that same 25 PSI error still applies at lower pressures for full-scale readings. So if that measurement instrument is being used to measure 500 PSI, then the absolute error still remains 25 PSI. This is where accuracy specifications must be evaluated in context. The question isn't whether the instrument meets its stated accuracy, but whether that accuracy is appropriate for the pressure range and the tolerance requirements of your specific application. The solutions, you can move to a significantly more accurate instrument. There's instruments that have 0.05% full-scale accuracy, 0.00% full-scale accuracy. That reduces your absolute error across your range, but it typically comes with increased cost. Another common approach is to use multiple gauges with different ranges so that each instrument is taken closer to the full-scale measurement. This effectively adds inventory, though, calibration management, and instrument selection for your technicians in the field. The best solution, and the one that I often offer to address the limitations of full-scale base accuracy, is to use % of scale reading rather than % of full scale. So with percent of reading accuracy, measurement uncertainty scales with applied pressure. So as pressure decreases, the absolute error decreases proportionately instead of remaining fixed across the entire range, right? So instruments like the one you see on your screen there, the XP3i, use % of reading accuracy combined with temperature sensitivity to maintain proportional accuracy under real-world operating conditions. So from a practical standpoint, this reduces the need for multiple gauges with overlapping ranges while still maintaining tight uncertainty at lower pressures. It also simplifies your technician's instrument selection, or if you're the technician, your instrument selection. The key takeaway of this section is percent of reading accuracy aligns measurement uncertainty with actual operating pressure, making it far better suited for applications where pressure varies significantly across a wide range. If you're doing an application or you're working in an application where you're maintaining a fixed reading and it's close to the full scale of your instrument, then full scale accuracy could be the choice for you. So I just wanted to explain the difference between those two. Those are questions that we often get. If you have any questions on that, I can answer them at the end of the webinar. It's important that you understand that. So a little bit more on the XP3i. That was the instrument that you saw on the last slide. A few specifications. So it offers 0.5% of reading accuracy. It's also offered in full scale if you want that, but percent of reading as well, which allows it to function confidently as a reference gauge in the field calibration applications that you may have. As I previously said, it's temperature compensated. It has Bluetooth communication. All of this feeds into simpler and faster workflow, reducing time on site while improving your consistency and documentation. So calibration is a controlled comparison. So when we talk about calibration, it's important to separate the act of calibration from the tools being used and focus instead on what the process is actually doing. So calibration is fundamentally a comparison to a known pressure is applied and the response of the device, or the response of the device under test is compared directly against a reference. The result is a quantified difference at defined test points. So a common misconception that we'll see with customers is that calibration somehow improves the instrument's accuracy. I need to get a calibration on this pressure gauge so that it's more accurate. In reality, calibration does not change the performance of the instrument. It simply reveals it. It tells you how the instrument is behaving relative to its specifications at the time of your test. The effectiveness of calibration depends heavily on how pressure is applied and controlled during the test. Inconsistent pressure generation, unstable hold points, or poor resolution can introduce uncertainty that has nothing to do with your instrument being tested. So that's why calibration should be viewed as a controlled measurement process, not a procedural process. The goal is repeatability and comparability of results, not simply passing or failing an instrument. So building on the idea of calibration as a controlled comparison process, the next piece is how pressure is actually applied and measured during that process. So on your screen, you see a typical calibration setup. This includes usually pressure generation and pressure measurement as separate functions. So a calibration pump is used to apply and control pressure, while a measurement instrument is used to accurately quantify that pressure at different test points in order to calibrate your instrument. These systems are available as complete kits, which simplifies your setup by ensuring compatible components. From an application standpoint, once again, I'm using the same instruments here, but the XP3i is compatible with these AMETEK kits. It gives you your reference instrument, it gives you your pump and all of the fittings all in one package. Whether calibration is being performed with handheld pumps in the field or in a laboratory, it's a good setup for you to use. This approach reinforces the separation between pressure generation and measurement. That's going to be key going forward for us. So those AMETEK calibration pump systems bring everything together, but fundamentally they rely on three things. So a way to generate pressure, a trusted reference instrument, and a means to verify accuracy. We're now going to look into how pressure calibrators sort of incorporate all of those functions into one device. So in practice, the choice between a pump gauge setup and an integrated calibrator often comes down to workflow rather than accuracy. So integrated pressure calibrators are well suited for situations where speed and efficiency are priorities. Because pressure generation and measurement are combined into a single device, your setup time is reduced with fewer components. Like in that kit you saw, there isn't a bunch, but there are different components that go into it that using an integrated calibrator sort of brings it all into one, which minimizes your potential for error, your potential for leak points, It improves your ability to move quickly between test points. Pressure can be applied, adjusted, and held with minimal interruption. So overall, they just lead to a smoother and faster result during your calibration process. From a consistency standpoint, using the same integrated platform across repeated calibration tasks helps standardize your workflow. So whether it's one of these or your technicians are using multiple of these, using the same instrument and using an instrument like this helps improve your calibration efficiency and repeatability. So what technical characteristics must an integrated calibrator have to properly support your pressure calibration? If it's going to replace your traditional pump setup, it must provide measurement accuracy that is appropriate for the instruments being verified. So when calibrating transmitters or gauges in the field, the reference device must maintain a clear accuracy ratio so that overall measurement uncertainty remains controlled and defensible. Second, pressure generation must be stable and controllable. So it's not enough to simply reach a pressure value. The calibrator must allow fine adjustments so that test points can be approached gradually and held without overshoot or instability. Repeatability is equally critical. I just went over that. But during calibration, pressure must be applied, stabilized, and compared consistently, once again, across multiple test points. If the source drifts or fluctuates, it introduces uncertainty that has nothing to do with the device under test. Finally, in many field applications, electrical measurement capability is also required. So when verifying pressure transmitters, technicians also often need milliamp output as well, simultaneously controlling pressure, ensuring both the mechanical and electrical sides of the loop are performed as expected. So when these elements are all combined, controlled pressure generation, stable reference measurement, proper accuracy, and repeatability, the result is a self-contained tool capable of supporting pressure calibration without sacrificing your measurement integrity. So an example of this tool, up to this point, you've seen the Crystal XP3i. This tool on the screen, which you saw in the last two slides, is an example of the HPC series by Crystal. It integrates pressure generation and pressure measurement into a single handheld platform. It's available in both pneumatic and hydraulic configurations. It's built for field verification and calibration work. It's portable, it's affordable, and it's a great instrument for what we just covered. Just before we move on, some field applications for this, like what is this used for, if you're wondering. So they're frequently used for field verification of pressure transmitters, where technicians need to confirm accuracy on site without setting up multiple tools. It's ideal for commissioning your new equipment, especially during startups when multiple pressure points are needed. Remote, hard to reach locations where those full kits can't really get to, carrying a single integrated device makes a big difference. It's strong for troubleshooting. And then during your routine calibration rounds, which at the end of the day, that's the meat and potatoes of what this presentation is about, your calibration. This is a good tool as a reference tool to maintain faster and more consistent workflow. So sometimes we want to look a little bit deeper into a system and have a little bit more measurement flexibility. And that's where these reference recorders come into play. So the one that you're seeing on your screen there is the Envision by Crystal. At its foundation, it's not only a highly accurate reference standard for field calibration, but it's also your recorder. It can measure temperature, milliamps, and voltage. It's great for data recording, where your measurements can be logged automatically rather than written down or looked at after. You can see them in the moment. From an accuracy standpoint, it's extremely accurate, 0.025% of reading accuracy for pressure and 0.015% of reading for accuracy for temperature, milliamps, and voltage. It's a great instrument when you need to look deeper into a system to do diagnostics, and another really good instrument that Crystal offers. So after going over which model to choose based on your application, I just wanted to take a brief moment to mention some of the tools that ITM offers to make it as easy as possible for you to configure your model to your specific needs. So on the ITM website, we offer a configuration tool that allows you to start with the base version of a model. The three that I've mentioned so far all have this feature, the XP3i, the HPC, and the Envision. And essentially you work your way through a series of add-ons based on your specifications to build the tool for your needs. So you can see it in the image there. You have pressure range options, data logging options, pump systems, and pump case option. There's a scroll down to show your multiple options for each one of those features. Of course, if you're not exactly sure what you need, you could always reach out to our technical sales team and we can help walk you through this process. But it's just a really easy and simple tool for you guys to use to build the instrument based on your application. Before we move on, I just wanted to go over what we've spoken about from a instrument perspective so far. So the XP3i, the first one that we spoke about, it's all about reference accuracy. So it's a trusted reference gauge. It's used with the pumps and the calibration systems that I spoke about as well. When accuracy is your primary requirement, the HPC focuses on field calibration efficiency. It combines pressure generation and measurement into one device. It's ideal for fast on-site calibration and verification. And the Envision takes things a step further. It's designed for advanced field diagnostics. It has multi-sensor capability, the temperature, the voltage, the milliamps. And it's used when you need more visibility into your system, multiple pressures, different ranges, deeper analysis. It's a tool that's built for that job. So overall, I want to just pause and go over what we covered so far. So first, calibration protects measurement confidence. So across every industry we discussed, accurate pressure measurement directly supports control, safety, and reliability. Second, accuracy specifications must be evaluated in context. So we looked at the difference between percent of full scale and percent of reading and how that impacts usable accuracy across an operating range. The goal isn't to meet a spec, it's to ensure the spec supports your application. Third, calibration is a controlled comparison process. It doesn't improve your instrument, it reveals how your instrument is performing relative to a reference. The integrity of that comparison depends on the stability, control, and repeatability of your calibration processes. And finally, we discussed how the different tools support different stages of pressure work. Before we get on to our next agenda point, I just wanted to let everyone know, I believe you got a notification saying this, but everyone in attendance today and who stays until the end of our Q&A session will get or will be automatically entered into our contest to receive $100 off your next ITM order. So you don't have to do anything, just stay until the end of the Q&A discussion and you will automatically be entered in this. So calibration management and best practices. So up to this point, we should have a pretty good understanding of the basics of pressure and calibration, as well as the tools and instrumentation that Crystal offers to ensure these processes are done correctly, efficiently, and to industry standard. We're moving on to calibration frequency and best practices here, which in essence means how calibration should be done when things are working properly. So we'll go over traceability and compliance, and we'll end with the risks of skipping calibration before going into the key takeaways and our Q&A. So how calibration should be done when things are working properly. When it comes to calibration frequency, the most common interval you'll hear is somewhere between 6 and 12 months. This is often stated by manufacturers. So when you buy a tool, they'll tell you, hey, this comes with a calibration certificate and it needs to be recalibrated every 6 to 12 months. At the end of the day, calibration should not be driven by calendar. It shouldn't be driven by any sort of set date because there's no one size fits all answer to this. The right frequency is risk-based. So it depends on how critical your measurement is. It depends on how often the instrument is being used, and it depends on the environment that it's operating in. So the key takeaway here is there's no one size fits all answer. Two gauges could look identical on paper, they can be the same model gauge, but they can require two very different calibration intervals once they're put out in the field based on these external factors. So what actually determines this risk? I just spoke about it a little bit there, but the biggest one that I typically speak with customers about is the operating range. So instruments that regularly run near the top of their range tend to experience more stress and may require more frequent calibration. Frequency of use plays a major role as well. Pretty obvious one, but if a gauge is used daily, it's going to require different recalibration needs than a gauge that's used occasionally. Environmental conditions matter as well. So temperature swings, vibration, moisture, or harsh process conditions can all accelerate the drift. And finally, process criticality. So if pressure reading is directly impacting the safety of you as a technician or your technicians, that's something that you're going to take more seriously than if it's not, because simply the risk is higher. So it really depends on your application, and it depends on external factors. The 6 to 12 months that you hear is really just a rule of thumb, for lack of a better term. Traceability. So this is very important. When we talk about traceability in a technical sense, we're sort of referring to an unbroken calibration chain that's recognized all the way back to national standard, most commonly NIST. Every reference standard in that chain is calibrated on a defined schedule with documented accuracy and known measurement uncertainty. There is a distinction between those two. Accuracy tells us how close a measurement is to a true value. Uncertainty tells us how confident we are of that result once we take into consideration all influencing factors. So reference accuracy, resolution, repeatability, environmental conditions, operator technique, all of this is taken into consideration. In a properly traceable calibration, uncertainty isn't ignored or assumed. It's calculated and documented. The end result of traceability is confidence that a pass is truly a pass, that a fail is truly a fail, and that measurement data can stat up during audits, safety reviews, investigations, etc. So once calibration frequency is defined, the next step is making sure the calibration itself is done correctly. One of the most widely accepted best practices is using a reference standard that's at least 4 times more accurate than the device under test. This ensures the calibration results are reliable and reduces uncertainty in the measurement. Calibration should be performed across the full pressure range, not just a single point. Pressure instruments don't always drift evenly, so checking multiple test points allows you to sort of break any linearity that might be going on. And this brings us to one of the most important practices that, once again, I often tell this to my customers if they're looking for new methods, performing as found and as left readings. As found data shows you exactly how the instrument was performing when it came out of service. It tells you whether the gauge was still within tolerance, how much it had drifted if it had, and whether there may be any developing issues with the instrument or the process itself. As left data confirms that the instrument was properly adjusted and returned to specification before being placed back into service. So together, as found and as left results in a clear and historical record of performance over time. This historical data is extremely valuable. It allows you to identify trends, justify calibration intervals, and catch potential problems early. So how does Crystal Engineering support traceability and compliance? So all Crystal instruments, all 3 that I spoke about during this webinar thus far, and their entire catalog is supplied with NIST traceable calibration certificates. Those certificates clearly state both accuracy and measurement uncertainty, which supports proper test accuracy or uncertainty ratios and allows your calibration decisions to remain defensible. From a quality and compliance standpoint, the documentation is critical a lot of the time. Customers ask all of the time if it comes with traceable certificate. In this case, Crystal Instruments do. If you have stricter regulatory compliances or requirements, They have an ISO 17025 accredited calibration available as well, but this does not come with the instrument itself. In addition to the manufacturer calibration services provided by Crystal Engineering, ITM Instruments also supports customers directly through our own accredited calibration laboratory. Our lab provides NIST traceable calibration across pressure and a wide range of instrumentation. So beyond the calibration itself, we also support customers with interval evaluation, asset tracking, and ongoing instrument lifecycle management. If your fleet grows, this can be critical. So all in all, from a practical standpoint, this means that you can rely on us not only to supply you with your instrumentation, but to help you with your calibration processes, calibrate your gauge ourselves, answer any questions that you may have, and ensure long-term performance traceability and regulatory alignment throughout your instrument's life cycle. So the risks of skipping calibration. So all pressure sensors experience drift over time. This drift can result from normal sensor aging, repeated pressure cycling, mechanical stress, exposure to environmental conditions like we spoke about, vibration, moisture. As that drift occurs, there is a gradual loss of measurement accuracy. The change is typically incremental, not sudden, which makes it more difficult to sort of recognize if you're not trained to. For lack of a better term, the reading values appear reasonable. Like they're not egregious and they're still within an acceptable range. And because there's no obvious failure or alarm, the instrument continues to be trusted. The issue is that this deviation often remains undetected if you're not doing your calibration. And without verification, there's no objective way to confirm whether the instrument is still performing within its specified tolerance for your application. Over time, that unnoticed deviation becomes embedded in the process, and your measurement confidence slowly erodes without anyone realizing it. When calibration is delayed or skipped, the immediate concern is often measurement accuracy, but the downstream impact is much broader. So from an operational standpoint, inaccurate pressure measurements can cause systems to operate outside of their intended design limits without triggering any alarms. Even if those deviations seem relatively small, they increase mechanical stress on your components, such as pumps, regulators, valves, and it can shorten your equipment's life cycle and increase your maintenance frequency. From a compliance and quality perspective, uncalibrated or undocumented instruments create risk even if the process appears to be operating normally, because your measurement data collected during that period may be considered invalid or non-defensible during your audits or your inspections. Financially, these impacts tend to be indirect and cumulative rather than immediate, but the unplanned downtime and the emergency maintenance that's required usually increases the operating costs significantly and causes major issues. So taken together, skipping calibration doesn't just increase technical risk, it erodes your operation, and it drives your avoidable costs of maintenance and production through the roof. As a final point here, just to address recalibration and how calibration intervals are managed over time. In many pressure applications, 6 to 12 months is a baseline. However, like I said, your recalibration should really be risk-based, application-based, not a fixed calendar assumption. In practice, recalibration decisions should be informed by historical calibration results, particularly your as-found data and your observed drift over time. Instruments that demonstrate stable, repeatable performance may justify extending those intervals, while instruments that are exposed to higher stress, harsh environments, and continuously don't meet those intervals, you should probably be recalibrating more often. Ultimately, recalibration isn't about meeting a prescribed schedule. It's about maintaining measurement validity, controlling uncertainty, and ensuring that your data remains reliable for its intended use. So, calibration protects measurement confidence and keeps your process under control. Accuracy isn't just a number on a data sheet. It has to make sense for your application. Calibration is a controlled comparison, and it only works if your reference is accurate and traceable. Calibration frequency should be based on risk and real performance data, not just a date on a calendar. And finally, skipping calibration doesn't cause immediate failure. Well, sometimes it does, but doesn't always cause immediate failure. It introduces silent risk that builds over time. So everything we've covered today, accuracy, calibration practices, traceability. I hope I got this message across, but at the end of the day, it all comes down to applying the right approach to your specific environment. That's typically how I work with my customers. A lot of the conversations that we have aren't about products. They're about solving your problems, whether that's improving your consistency, reducing your downtime, or just going over what you're using and how it can be improved. That's where I can come in and help. So if anything, if you've gained anything from today's session, it's that you can always reach out with any questions, and we can go over your application and your specific needs and come up with the best solution possible. Feel free to reach out and connect to us through our website. We're always open for conversations. Chris?
Well, that is a whole lot of information in a pretty good amount of time. So let's get going with our Q&A. So it is the portion that we have left. We have plenty of time now. We have about 20 minutes or so. We do want to be respectful of your time, but it is great to take advantage of having an expert like Kevin with us today. So if you do have any questions, please use the chat feature, put them in there. In the meantime, if you have any specific questions related to your specific application, what you currently have, and whether or not it's the best instrument, the best tool, the best gauge, the best thermometer, something like that you currently have or looking to upgrade or something like that, something specific like that. Ideally, we'd like to talk to you and contact you directly. So the best way to do that is go to our website, itm.com. There's a contact us button on there. You can find the three best ways to contact us: via email, via phone, and via live chat. And any questions that are application specific, they'll be directed to our technical sales team, which includes myself, Kevin, etc. For any questions related to price, availability, you want a data sheet, manual, anything like that, same thing, itm.com. That's the best way to go about it. And again, you can reach out via different ways to contact us, where if you want a formal quote or anything like that, we can do so there. So again, let's please use the chat feature for any questions. There is a Q&A feature as well, if you're more familiar with that and prefer to use that. Both of them work. But like I said, let's try and get these questions in while we have Kevin on with us. So a few questions for you, Kevin. In terms of that precision ratio, when you were talking about reference to calibration, how specific do we need to stick to the 4-to-1 ratio, the 3-to-1 ratio? Are there certain applications where that type of accuracy is more important?
Yeah, so the 4-to-1 it's titled best practice because it's really a best practice, but it's not a end all be all. Typically, with how accurate today's instrumentation is, a 3-to-1, a 2-to-1, and even sometimes a 1-to-1 is okay. But once again, to sort of go back to the theme of sort of this webinar, it's application dependent. Obviously, the more accurate, the better. So the higher that ratio, the better. I would say that if safety is a risk, or if the cost of your downtime is extremely high, going to a 2-to-1, a 3-to-1, in a perfect world, a 4-to-1 would be my recommendation. Where if you're doing something that's a little bit more basic, using a one-to-one could even be a process for you to use. But the main thing is that a one-to-one isn't a waste. You know, it's not a throwaway. It's still good data. It's still reasonable. But as the stakes are higher, the higher the ratio.
Right. Okay. So it really is application based primarily, but there are ways around it, or
Yes.
it's not an exact science. Okay,
Yes.
that's good to know. Okay, well, and you did mention something which is a great segue into this next question is, do you have any specific tools or information that you use, or that we can share with those of us on the webinar today about the tools that we can use to calculate ROI and to calculate the investment of a high accuracy tool like the few that we talked about today, and how it all evens out and equals out.
Like, can you, in terms of like the customer's ROI by proceeding?
Yeah.
I mean, reduced rework, fewer failed calibrations, improved efficiency, all of that in the field can build a clear ROI on getting a better instrument or a more accurate instrument opposed to something a little lower. At the end of the day, and maybe this answers your question, Chris, maybe it doesn't, but when I sell a extremely high-end accurate instrument to one of my customers, there are rarely any complaints. It typically works for what they're doing, and they're happy to have it, and it saves them money going forward by not needing to redo their work, and by not having greater issues. So I'm not sure. I'm hoping that answers at least a part of your question, but that's what I would say.
Yeah, no, I think it's a good answer. The one thing I will say, in terms of the experience that ITM has, myself, Kevin, and the rest of our technical sales staff, we work with ROI on a daily basis and can help guide you too. So if you're listening on this right now, whether it be live recording, anything like that, and you're having trouble in terms of trying to get that calculation to move on and get the approval for this type of investment, ITM and our technical sales team can help you calculate that ROI, or provide you with the specific tools for your specific application to be able to calculate that ROI to get the approval for the business investment. Again, ROI, it really is the nature of a lot of these types of investments for the betterment. So we are very well practiced in this type of question, in this type of environment. A quick reminder: we have about, let's say, 15 or so minutes. Again, being respectful of your time. We do have Kevin on with us, so please let's try and take advantage of the fact that we do have an expert like Kevin, someone who is really well experienced in this type of field with these types of instruments. If you have any questions related to price, availability, technical data sheets, anything like that, go directly to the website, itm.com. And again, anything product specific or application specific, I should be more specific, we'll address directly with you after the webinar as well. Let's see what else we have. Just bear with me a second here. We did kind of cover this already, but can we, because of how often we'll get these types of questions, Kevin, the difference in the comparison between percentage of full scale and percentage of reading, right?
Yeah. Yep.
How would individual users of these gauges decide which is best for them?
Chris, that's good. And there's actually a question in the chat that I can sort of use in as an example for this. So Jared said, what happens with accuracy if you use a measuring device that is rated 0 to 10,000 PSI on lower end processes? So 0 to 1,000 PSI. And Jared, what happens is that your relative error is significantly larger if you're operating in the 0 to 1,000 rather than closer to your full scale at 10,000. Because your error is still, if you're using a full scale gauge on that, you're still, whatever your accuracy percentage is now going to be applied to the 0 to 1,000 rather than the 0 to 10,000. So it's going to be within that window. Hopefully I'm being clear when I say that, but that if I'm not sure what your accuracy percentage is, but your instrument is going to be a lot more accurate when you're operating close to that 10,000 range relative to when you're operating at that 1,000 range if you're using a full scale percentage, if that's the setting and that's the specification on your gauge. Now to go on to Chris's question as sort of a solution to this, if your gauge is a percent of reading gauge, then your relative error is going to be proportionate. So it's going to be the same at 1,000 PSI for you as it would be at 10,000 PSI. So whether that's okay, like I've been saying, that's going to depend on your application. But my solution to you, Jared, would be to either get a percent of reading gauge if your operation is going from 0 to 10,000 and you're operating at different PSI pressures along the way, or to get multiple full scale gauges. So perhaps having one that has a 1,000 PSI full scale reading to use then, and then perhaps have one at 5,000 and then perhaps have one at 10,000, depending on what your operating ranges are. So that would be my answer to both your question, Chris, and to Jared, to you as well. Hopefully that's clear.
I think that's great. That's a very, very well detailed. And Jared, to go over all the options, all the specific options of the XP3i model or anything similar to it, shoot us an email, give us a call. Myself, Kevin, or anyone in our team will be happy to walk you through all the different options that you have for you specifically. Ram, you have a great question in terms of the ratio as well. Kevin, I'm not sure. So this webinar is really based on pressure. That being said, Kevin, if you want to take a crack at this from a calibration standpoint, Ram has asked, is the 4-to-1 ratio the best rule of thumb to apply when calibrating calipers, micrometers, height gauges, etc.?
So Ram, I work with Metatoyo, and I sell a decent amount of calipers, micrometers, and height gauges. Typically, that stuff gets calibrated at Metatoyo. If I had to guess, they are likely calibrating at 4-to-1. That being said, I am not entirely sure. I'm not entirely sure of that. That is something, though, that you can email me. Like Chris just said, you can reach out and I can get that answer for you in no time. Like I said, I do have a decent amount of experience selling that as well. So I know who to reach out for to get that answer for you if you need. I would think that, yes, from a calibration perspective, it's sort of a rule of thumb across all industries, that 4-to-1. But application and what laboratories are doing for specific instruments, that I am not entirely sure of. So I would have to reach out to give you a better answer on that if you need one.
Yeah, and I think so it's a great question. Thank you, Ram, and a great answer. I think rule of thumb is realistically when you're going to be checking anything from a calibration standpoint, the most accurate reference tool that you're using compared to what you're looking to calibrate and or check, if you can get the most accurate as possible, go with it, right? It saves a whole bunch of questioning and uncertainty the more accurate you get, regardless of the type of instrument and application. We have about 10 minutes left. Sim, I do see your question. I appreciate it. What we're going to do is we're going to save this question and we'll be able to address it to you specifically and directly. Either, again, myself, Kevin, or one of our teammates will be able to address this specific question with you directly. So give us a day or two and we'll contact you directly to be able to walk you through the best option for you. Again, a few minutes left. If you want, try and get your questions in. Great opportunity, like I said, to have Kevin on with us today. So please feel free. Anything specific, go to itm.com. You'll find the list of our model numbers, pricing, availability, data sheets, everything in the like. You'll be able to find it at itm.com. So please go for it there. We'll leave about 30 seconds or so if any more questions do come in. If not, we're going to give you back about 8 minutes of your time and let everyone off the hook early today. So we'll wait about 30 seconds. If you have anything else while waiting that 30 seconds, if you have, everyone has those light bulb moments that as soon as we press stop, someone's going to have a question and, smack themselves in the head. I should ask the question. By all means, itm.com, contact us. Information at itm.com is the best email address to send us any requests, as well as giving us a call on our phone number. We have a live chat as well with our customer service department, so we can help you out in that sense. Let's see. All right, another question from Ram about the risk-based calibration frequency. The standard rule was equipment used at the high end of the range needs higher frequency. And pardon me, I just have to expand this. Okay, so Ram, being that this is specific to a caliper, we'll take this offline and answer this directly with you, just so we can, I guess, be respectful of the overall subject of today's webinar, where it is really pressure-based. But these are great questions. Again, either myself, Kevin, or a teammate will address this specifically for you. That way we can engage in a better dialogue overall. Let's see. Okay. Well, we have about 7 minutes too. There's a lot of information that was passed along today, a lot of questions, a lot of great questions. Thank you very much for being an engaging audience and taking part in today's webinar as well. Thanks for giving us your time. Kevin, thank you very much for all the information and a great presentation as well. So on behalf of ITM University, again, thank you very much for joining us today. If you have any follow-up questions, I think I've mentioned it a good enough amount of times now, but hey, just for one more crack at the barrel, itm.com is the best way to get all the information that you need. If you do need something more specific, by all means, contact us, email, phone, or chat. And as a thank you again for attending all the way up to this very moment, your name will go into a draw for a $100 credit towards your next online order. The winner will be announced on our social media channels as well as contacted directly. So take a look there. And again, thank you very much for your time. Thank you for engaging with us. Hope you found everything informational and informative. And we hope to see you again at the next one. Have a great day, everyone.